There are discoveries that dominate the news for a few days. Others reshape entire fields of science. And then there are the rare discoveries that leave even experienced astronomers wondering whether some of our deepest assumptions about the universe need to be reconsidered. That is the discussion unfolding after the latest findings from the James Webb Space Telescope. For decades, scientists believed they had a solid understanding of how the universe's earliest galaxies formed. According to the standard cosmological model, the first galaxies should have been small, dim, and irregular, gradually growing over hundreds of millions of years as gravity pulled gas and smaller systems together. But when James Webb pushed farther into the cosmos than any observatory before it, the universe revealed a very different picture. Instead of finding only tiny, primitive galaxies, Webb detected remarkably bright, compact, and unexpectedly massive objects dating back to an era when the cosmos was still in its infancy. Some appeared far more developed than existing models had predicted, raising questions that researchers are still working to answer. The discoveries quickly became the focus of intense scientific investigation. Could galaxies in the early universe have formed stars much faster than expected? Have astronomers underestimated how efficiently matter gathered shortly after the Big Bang? Or is there an important piece of cosmic history that current theories have yet to explain? Each new observation has added another layer to the mystery. One object, in particular, stood out almost immediately. Hidden among thousands of faint points of light in one of Webb's deep field images, it initially seemed ordinary. But detailed analysis told a completely different story. Its light had spent more than 13 billion years traveling across space before finally reaching Webb's mirrors. That meant astronomers were seeing the object as it existed only a few 100 million years after the Big Bang, a time when galaxies were expected to be just beginning their formation. Yet this distant object appeared surprisingly bright and unusually organized. Rather than resembling a loose collection of newly forming stars, it displayed characteristics of a system that seemed far more mature than expected. Naturally, researchers questioned the measurements. Was the distance estimate wrong? Could another object along the same line of sight be affecting the observation? However, follow-up spectroscopic measurements, the most reliable method for determining a galaxy's distance and composition, confirmed the surprising result. The galaxy truly belonged to the earliest chapter of cosmic history. And soon, astronomers realized it was far from unique. As Webb continued exploring deeper into the universe, more ancient galaxies with similar properties began appearing in its observations. With every new discovery, existing models faced fresh challenges. Instead of uncovering only a handful of unusual objects, scientists found an increasing number of bright, distant galaxies existing much earlier than many simulations had predicted. This transformed what first appeared to be an isolated curiosity into one of the most important scientific debates in modern astronomy. Deep field surveys are designed to capture the faintest and most distant light in the observable universe, allowing researchers to witness galaxies as they existed billions of years ago. Scientists expected these images to reveal a young universe slowly building its first structures. Instead, Webb revealed a cosmos that already appeared surprisingly active. Many of the newly detected galaxies seemed compact, extremely luminous, and capable of producing stars at remarkable rates. Some researchers now suggest that star formation during the universe's earliest epochs may have been significantly more efficient than previously believed. Others argue that young stellar populations naturally produce extraordinary amounts of light, making these galaxies appear larger and heavier than they actually are. Both explanations remain under active investigation. Yet neither one fully explains every observation collected so far. Independent research teams continue analyzing Webb's data, comparing it with advanced computer simulations in an effort to understand whether these unexpected galaxies can be explained within existing cosmological frameworks, or whether new physics may eventually be required. This is the strength of the scientific process. Unexpected evidence doesn't immediately overturn established theories. Instead, it encourages scientists to challenge assumptions, refine calculations, improve simulations, and gather even better observations. Today, astronomy stands at one of those exciting turning points. The James Webb Space Telescope has provided humanity with its clearest window into the universe's earliest history. For the first time, researchers can directly observe galaxies that formed only a few 100 million years after the birth of the observable universe. Every image carries new clues about the formation of the first stars, the growth of the earliest galaxies, and the evolution of the cosmos itself. With every discovery, one mystery becomes clearer while several new questions emerge. And perhaps that is James Webb's greatest contribution, not simply giving us answers, but revealing just how much of the universe still remains unexplored.